Welcome back, everyone. We're going to be solving LeetCode 144, binary tree preorder traversal. So we're given the root of a binary tree. We need to return the preorder traversal of its nodes values. And this is going to be a depth first traversal. So if you don't know what that is, essentially what we're going to do is we're going to start at the root of our tree, and we are going to traverse all of the nodes all the way down to the bottom of the tree on the left hand side, and then we will go to the right hand side. So and depth first uses a stack where breadth first uses a queue. So in this case we do not have to import dq from collections. We can just create a stack, make it an array, and they want an output of the node's values. So we are going to have a resulting array. Okay, so we run depth first search while there is something in our stack. So we are going to start with the root node on our stack. So we'll say while the length of our stack is not equal to 0, and you could also say, while stack, while it's still truthy, but I think this is a little more concise. So while the length of the stack is not equal to 0, meaning we have nodes on there, we are going to do something. What are we going to do? We are going to grab the node. We are going to say the node is going to be equal to our stack.pop, right? The very last node on our stack, which in our first iteration is just going to be root. So what do we want to do? Well, first we want to check and make sure that the node is non-null. So we'll say if node is not none, then we will do something. So let's do this, and at the end, after we break out of this while loop, we are just simply going to return our resulting array. Okay, so after we have our node and we know that it's non-null, what do we want to do? We want to append the node value onto our resulting array. So we will say res.append node.val. Now we need to go left. We need to go all the way left before we go right. So you might be thinking, if node.left is not none, then we can just say stack.append node.left. Right? We're also going to have to check the right node, but let's see what happens when we do this. We'll actually get the wrong answer. Right? So if node.right is not none, we'll append right. So let's run this. Now it does say we pass all 3 test cases, but it will fail. Right? See, it grabs 3, 2, 1 as opposed to 3, 1, 2. So what does that mean? It means our algorithm is favoring the right hand side of the tree before the left hand side. So in order to fix this and get the right answer, we can just say, okay, well, after we append the node value onto our resulting list, let's just grab the right node and append that onto our stack before we append the left node. Now we can run this. We'll see it passes all 3 test cases, and we can submit, and we see that it passes the submission test. Okay, so let's get rid of some spaces here. What is the time and space complexity of this problem? Space complexity is going to be bound to the length of the stack plus the length of our resulting array. So it'll be O of stack.length plus res.length, which is just going to simplify down to O of n, right? And the time complexity is going to be O of n, right? We are touching every single node in our tree at most 1 time. So that is going to make our time complexity O of n, where n is the number of nodes in our tree. All right, that'll do it for LeetCode 144.